record it like I did last time. People seem to watch it on YouTube and enjoy it.
Yeah, that's really nice. You're a good host.
Oh, thank you.
Trying to find myself here. Oh, wait a minute. Okay, there we go.
Sweet.
Yeah, I'm holding an iPad. Okay.
Yeah.
Well, yeah, in the interest of not wasting time, I want to build something like a Tetra 606. I've always been I've always wanted a speaker that used an AMT driver, and I've always been intrigued by the ATC, the Volt/ATC mid-range driver, and yeah, that's a picture of it. And I talked to Dana a little bit. I've been working for the last 12 straight days, so I'm a little bit incoherent, but and I'm also a big fan of transmission lines, which aren't going to work. But Dana actually found, I think, what is the exact ATC driver and the Mundorf driver, and he found a really great 12-inch woofer. And so I was thinking of altering the design a little bit to bring the woofer and mid-range in a little closer proximity to them, to each other, to allow for smaller room monitoring. So these are all expensive drivers, and the basic design of that unit itself, the tweeter is a dipole. It's open air, and if you look in the back of the mid-range unit, I think it weighs 20 pounds, but it's also open air. The woofer's in a sealed enclosure, and I was just thinking, if I can't build a transmission line, which is way too complicated, I think I would just move the woofer up closer to the mid-range and put an aperiodic port on the bottom. And I'm open to suggestions. I'm not saying I know what I'm doing, but that's. And also, I've been experimenting with my own speakers at home, and I found that about a 5-degree tilt back seems to result in the best stereo image and sweetest sound. So that's kind of what I'm going for. The speaker probably won't look as elegant as the Tetra 606, but I'm hoping it'll sound somewhat similar. And all of these drivers you can get in 16 ohm versions if necessary, and Dana suggested some active crossovers, so that's what I'm thinking about. End of story. Any questions? And if not, that's okay too.
How efficient are they?
Pardon?
So just to put this in perspective, these Tetra speakers are commercially available, and I believe they cost around $30,000 or something. Is that correct? Yes?
Yes.
Yes. So the idea is to see if we can get the same drivers as the Tetra system and make your own, basically for, 1/10 of the cost
Yes.
of what you would commercially. That's the goal. And also that these Tetra speakers sound very good. You've read reviews, and have you ever heard them yourself?
I have not. I've heard speakers that have the various drivers in them.
Awesome.
Hello, audio. Where's everybody? Hello, audio.
Hey.
Hey.
We hear you, Renee.
Hey.
It's just an experiment. I've had the same loudspeakers for I've had transmission line loudspeakers by the same designer for the last 40 years. So I'm just, in general terms, I'm ready for something new, and I've been looking around a lot, and this is what I. Yeah.
Good idea.
Yeah.
What size is your listening room, Tim?
Right now, the listening room is about I want to say 12 feet deep and 20 feet wide. It's not ideal. It's not an ideal listening room. But it's what I have.
Right.
So that's why I was going to reconfigure these a little bit so that they would work in more of an almost near field situation.
They must have that large woofer. It's a 12, I think, down near the floor. They must have that to gain some boundary boost for the low end. Otherwise, why would they, put it so far away from the mid-range? But you might not. Maybe in your room it wouldn't be so important to have that. When I looked at those speakers, Dana told me you were doing this project, and I looked at those speakers, and my thought was, boy, those are probably designed to fill a big living room,
Right.
So yeah, you might be able to do some modifications there.
I do know the woofer is ported, and
Yeah.
I don't know that you can get the exact woofer. I think it's sort of custom built for the Tetra, but Dana came up with a really nice one that might actually be better. I think it's an SB driver. So.
And then you'd cross over around 500 hertz.
Yes. Yeah, that's one of the important things to me, is that the integration between the woofer and the mid-range, which is a large mid-range, is seamless as possible.
Yeah, I mean, do you remember, does anyone remember what the crossover the Tetra had between the woofer and the mid?
Yeah, I think they were like 1,000 hertz and then 3,000 hertz up to the tweeter. So it's kind of interesting, but that's what they say. What are they actually? I don't know. But
Yeah.
Right. I mean, it's that it's a 3-inch dome. Is that ATC mid-range is a 3-inch dome. So you could probably go a little lower if you didn't need it to go quite as loud. I think they maybe made that to go a little louder in a big room, and that if you crossed it over too low, I think that isn't the resonance on that mid-range like 300 hertz or something?
yeah, I think it's pretty low. It's in the maybe 400, but yeah, it's down. There's a lot written about it. It's if you start searching, I actually found that Voice Coil Magazine did a write-up on it in September of 2017,
Mm-hmm.
and then Jeff Bagby did a nice write-up on it. Just trying to think, where did my share deal go? I was going to show that, but I lost my button. Oh, there we go. I could show a couple of those things. So here's the, will that work? Oh, there it is. So this, yeah, Jeff Bagby just got a hold of one several years ago. And, but yeah, it gets you an idea how big the magnet is on the back of the thing. It mounts from the rear because the magnet's larger than the front of the driver. But yeah, here he shows it in a speaker he built, and so that's kind of, yeah. If you're looking for ideas, he's also. There are various people have built these. Oh, here's some stuff. So where's that? That says the resonance 100, 200, 300. Yeah. So that's. There's the response in the mid-range, I guess. Yeah. So anyway, I won't hog the screen
Looks like
here
you want
too much.
like a fourth order high pass on it, and you could push it down to about 500 hertz.
Yeah. And so that's what, I was recommending Tim use a digital crossover, because then he can just change it daily. He can put on the remote first order, second order, fourth order. Because I think, yeah, there could be quite a bit of tuning to taste. Yeah, getting that transition between a 3-inch, although it's nice, it's a waveguide mounted for the 3-inch dome to help it go a little lower, I think. But between that 3-inch and the 12.
I mean, if you think about like comparing like a a two-way with a 6.5-inch mid-bass, something like that, crossing over at 20 or 2000 hertz. It's a similar kind of relationship, just all shifted down.
Yeah.
You know, like a 1-inch dome tweeter to a 3-inch dome and a 12-inch. It's a similar kind of a relationship. So you might have similar kind of a situation, but down at 500 hertz, it's not going to be nearly as problematic as if you had a little misalignment right in the middle of the vocal range.
Yeah.
Upper mid range. Probably worked out really well.
Yeah.
But it's just not going to have as much power handling at 500-600 hertz as it would at 1,000.
Right.
But if you don't need, I mean, you probably don't turn your stereo up that loud most of the time. So.
Yeah.
Yeah. And then the using those digital crossovers can be a starting point if you also want to make a passive crossover at some point. You can kind of play with it and find out what works, and then you won't have to spend so much on all the little coils and stuff until you get to the right point.
Oh yeah.
Hey, I have a question for all of you, Howard and Dana and everyone else, and Renee, and Dave and Renan, everybody. These devices, the ATC or the Volt driver, and I think all three drivers are made in 16 ohm versions, and I'm a bit of an old horse. So, and actually the speakers I have now have a bunch of 16 ohm and I think 11 ohm drivers in them. So I don't understand why people don't make 16 ohm drivers anymore. And I was just wondering if I were to use 16 ohm drivers, would that make an easier load on the amp? Could I build eventually a series crossover, or I'm just trying to build something that's easier to drive and maybe sounds nicer. And I don't know if the difference between 16 ohms and 8 ohms makes a difference, but since this is a DIY project and I just mostly want to listen to the stuff, should I even consider 16 ohms, or are the 8 ohm versions the easier way to go?
Are you using tube or solid state amplifiers?
Well, right now I've got a solid state amplifier.
You'll get more power with the lower impedance.
You get more power with a lower impedance? Yeah.
Yeah, with tubes though, you get a better match if you go higher, assuming that your output transformer has a 16 ohm match. Now, if you have a 16 ohm tap on a tube amp, then it's an easier match for the transformer to use to drive a higher impedance.
Well, one of my tube amps, or two of my tube amps, have 16 ohm taps. The Premier 8 that you worked on with me, that just has a single tap, and I don't know where they don't specify where the transformer's tapped. So.
Well, if you do get around to doing your passive crossover, I believe that if you had a 16 ohm woofer, that you would need twice as big of a coil for a given frequency as you need for an 8 ohm. And so if you're going to cross over low passive with a if you're going to cross over low, in other words, low pass, the woofer, actually the lower ohms in the woofer, you just don't have to buy as big of a coil. And my experience drops off at knowing all the particular electrical relationships that can happen in terms of things limiting, you get too big of a coil and you get the wrong interaction with the driver and whatever. It doesn't always work out. So I think Dave knows more about that. But I've had the problem with some woofers of putting a larger coil, and then it causes weird, like I'm trying to make basically a subwoofer crossover with a coil, and then I end up with weird big bumps up around 800 hertz or something like that, and that weren't there before. They weren't there just with the raw driver. But then other woofers work fine, like the big 18s that came from Mackie through Renee. They worked fine with a 20 millihenry coil, which is a pretty big coil. Basically starts rolling it off around, I think, 40 or 50 hertz or something like that. Doesn't do it very quickly, but anyway, so that worked, but on other ones it's caused problems. So I don't know. What do you think, David? Does it matter the interaction between a coil like that and the impedance of the woofer? Would that have an effect on those kind of possible problems I'm talking about?
I think it helps to have all of the drivers with the same nominal impedance, like all of them 8 ohms or all of them 16 or whatever.
Okay.
You can make the crossover seems to be easier to find the right components when you do that. Although series sometimes it takes a while to bounce around to get final configuration on it. But it just all depends on the drivers and the response and the impedance curves on each one individually. I guess I don't have much help on just generalization on that. I'd have to get some formulas out to recall some things on that, some details on it.
I think Dana has the right idea. You really want to use a DSP at least between the woofer and the rest of the system. So you can play around and have separate amplification, because that allows you to adjust the crossover as it sounds. Also, it allows you to compensate for the different efficiencies, because until we figure out what the efficiencies of each of these drivers are, we don't know whether we can make a simple crossover all at one impedance or not. So
Yeah, it looks like the Mundorf tweeter's an 8 ohm tweeter. I don't know if you found a Mundorf at a different impedance, Tim, but yeah, my only thought was looking at, like reading Doug Self's book on amplifier distortion. He was talking about, well, as you get to lower impedances, 4 ohms and 2 ohms, you get that higher distortion out of an amplifier because the what was it, the gain of the transistors changing with the impedance anyway. But so 8 ohm is a relatively easy load for a transistor amplifier, and above that, I think you're, at least with transistor amplifiers, I think most of the stuff's designed to work with 6 and 8 ohms, and so all you're doing is having to buy twice as big an amplifier when you go to a 16 ohm to get the same watts. Yeah, but
got it. Okay, so points well taken. Just stick with 8 ohms. Stick with 8 ohms and start with the DSP, and maybe stick with it permanently. But at least that'll allow for modeling what you want it to sound like.
Oh yeah.
Under a bunch of different. Okay, thanks. Yeah. So that answers all my questions. Thank you.
Yeah, I'll share the screen here real quick on the tweeter. Let's see if this will work. So we think this is the tweeter after staring at the pictures. And so this is it over at Matasound. And in the actual installation, it had a rectangular plate, and it turns out you can order it with a rectangular plate. So so I think that is as close to the drivers we could find. It had this interesting pattern of a shorter little segment at the top and bottom, and the number of segments matched. But yeah, it's 8 ohms, 130 millimeter. So that flange 130 millimeters across. But yeah, so it's should be fun. Well,
thanks for doing that research, Dana. Like I said, I've been working 12, 14-hour days the last 12 days, and so
yeah,
I've been a little bit. So that's an incredible time saver for me. Thanks.
Yeah. Well, then of course, what happens is when I look at stuff in the catalog, then I accidentally click buy. So I went ahead and bought those drivers
Oops.
myself.
Oh,
I was like, oh man, these look so cool. Howard's been buying stuff. I want to buy some stuff.
what are you gonna build a set of speakers with them?
Yeah, well, since my four-way speakers I built a couple years ago and used the last dragged in a couple of times, so I have a 12-inch woofer in a box just sitting there separately, and so then I could just build the baffle because it doesn't need any volume.
Right.
You know, I just need to cut another chunk of wood and mount those two drivers in it. I can set it on top of my existing woofer cabinet. And I already have the active crossovers in the amp, so I can just hook it up and we'll be down the road. So yeah, you can come listen to it and see what you think.
I was just gonna invite myself over, so yeah, that'd be great. Cool.
And then you'll go, boy, I don't like this. I'm doing something else.
Well, as far as prototypes go, before you commit to, I mean, if you want to make a nice one eventually, like a nice piece of hardwood or something, if you're going to make that big open baffle, there's, you know, a couple of different options you could use for materials and still make a solid, stiff thing of the right shape. You know, like you could, like if you wanted it to be 1.5 inches thick, eventually you could laminate 2 pieces of 3/4 inch plywood together and just put a little glue in between them and shoot some screws in or something like that.
Yeah.
Or it would take a little more clamps and stuff like that and probably be harder. But you can also, I've been using construction lumber for my prototypes because I've been doing this thick open baffle, and I just go and pick through the stuff at Home Depot and look for stuff where I think I can work around the knots and end up with something that even looks okay. So there's a kind of a cheap way to do the wood if you want to do a couple of iterations of baffles before you commit to your whatever, you know, rosewood or Babinga or whatever.
Yeah. Well, and what do you think about MDF?
Most kind of really kind of into it. I mean, it's probably fine for prototypes and stuff like that. It's obnoxious to work with. It dulls your tools more quickly, and it's bad to breathe because it has formaldehyde in it typically. And it's really fine particle size. So if you do work with it, especially like with a router, you make just clouds of dust. So it's good to have a respirator with that. But otherwise, I think, you know, as far as just figuring out where the different refraction points and your placement of your drivers and the overall sound of the thing, no problem, you know. But most kind of speaker building snobs end up saying, you know, Baltic birch plywood if you're going to use sheet goods. But for the prototypes, you just get, you know, like Home Depot has this, if you're using plywood, it has this like radiata pine, and it's like, I think the unfinished stuff is like $37 a sheet or something. And the surface is actually real nice and smooth and everything. It's not, you look at the cross section of it and it's, you know, not the nicest plywood, but you know, not too expensive. But yeah, MDF is like for the ultimate thing is it's used in a lot of speakers and stuff, but you know, like I think it's usually the Baltic birch is recommended because it's stiffer and there's no internal voids in it, and it probably keeps its shape better. It doesn't, you know, so yeah.
Okay. Yeah, Baltic birch, it also looks nice.
It looks, I mean, yeah. I mean, it probably takes a stain okay, and it's not the fanciest looking grain, you know, but yeah.
Okay.
Yeah.
Well, thanks, you guys. I hope I haven't taken too much time.
If you do want to, mess with the MDF, the advantage of it is it's cheaper, and it does add quite a bit of mass, so that helps out there.
Yep.
I have used veneer on the MDF, and because it's got a real porous surface, you have to seal it first and make it a nice smooth surface for the veneer to stick well, unless you've got good vacuum bagging or something like that capability. But again, like Howard said, it's nasty to work with. You get lots of dust with it. It's already made up of dust particles, so, and then you're sawing it up and routering it up even finer, so the stuff just gets everywhere. So
Right.
Use
plenty of
cardboard.
ventilation and do it outdoors if you can. I set up the sawhorses in the backyard if it's nice weather and if I have to use it, but I do like plywood too, so.
Okay.
A good version of plywood.
And the Baltic birch is sometimes called Russian birch. And like at Crosscut, which is down in South Seattle, they sell, a lot of times instead of coming by 4x8s, it comes in 5x5 foot pieces.
Yeah,
Oh, yeah.
that's a European deal.
Right. That make a good ping pong table. Ping pong table's 5x10.
I think that you'd be better off if you used cardboard because it's cheap. You can get the shape you want. You can cut it up, you can change it, and then finally you can burn it and it's out of the way and you're not out of any money.
Yeah.
Amazon seems to deliver it free with each thing you order.
Yeah, that's right. So buy lots of stuff.
Can't figure out what to do. I bet 8 or 10 layers of cardboard, you'd be set.
Yeah.
Man,
I just have to get Amazon Prime.
there you go.
Yeah, okay.
You don't have Amazon Prime? We
I
found the last person on earth.
I did for a while. I just don't order enough stuff to.
Oh yeah.
Tim, if you want any help with the wood stuff, let me know.
Thanks a lot, Howard. And it looks like what you've got going on just to your right there, that's not unlike what it looks like. That thing with the 4 holes in it. Yeah.
Yeah, everyone's heard about the surfboard by now. It's what I've been working out details on for a while, and I eventually want to make one that has less drivers, make a design that I could share, because this one uses unobtainable drivers and stuff. But yeah, this is actually made out of 2x construction lumber, and it's I just cut around the knots, and but I've got a joiner, and I've got a planer, and I've got a pass-through sander, and that all helps a lot. And then a big router, a big plunge router with that you can put large router bits on, and that's what does the rounded corners. And it looks fancy, but and you have to have some experience with a router to hold on to one with a big bit like that, or do it safely. But it's not hard to do that type of thing. So yeah, that's what. This is the latest thing, and then the back side. I don't know if you can see is cut out. All the drivers are going to mount from the back side. These aren't cut out yet for the big woofers, exactly how they're going to be. But so basically, the drivers mount from the back, and then the front becomes a waveguide, and it's. Most of these waveguides, I've tested this one and this one with the drivers separately. I've made separate waveguides, and it doesn't do obnoxious things. Sometimes if you put a driver in a hole and put it too deep, it'll make funny bumps in the response, especially tweeters, especially mounted very deep. But so anyway, I was being annoyed with how my prototype was looking, and I was thinking, how can I make it all look kind of similar and not like a bunch of weird different looking drivers stuck on a baffle? So it's kind of where I'm going with that. And then this is going to be an open baffle 12, and down here is going to be a box 10-inch subwoofer, basically. But because the open baffle 12 really doesn't give you a lot of bass because of the cancellation.
Cool. Well, welcome, Max. I saw you joined. Looks like you're muted, so we're not going to hear your reply at the moment, but that's
Hey, guys.
cool. There you are.
Yeah, just a bit late,
Max.
but anyways.
Nice.
Yeah.
There you go. Somebody's got a phone call.
I got a phone call. Uh-oh, it's my wife. Hold on.
There we go. So anyway, Renan was interested in seeing Renee's workshop, and it looks like Renee has set us up so he can show it to us.
Oh, nice.
Yeah.
Cool.
Brilliant. Can we see your workshop?
You're looking at my workbench.
Let's see. Where's
Unfortunately, it's a backdrop right now. Thinking about like making a, doing a DIY thing of just the workbench, what all the stuff is and what it's for. My wife and I talked about it today, and she says, yeah, she says, I haven't done any movie making, so we have to think about how we're going to go about doing this. But, maybe like the weatherman, so you can, I'm here.
Oh, there you go.
Just point at it at the time.
Anyway, have the whiteboard and draw circles around it, and that's here. The big problem, of course, is it's backwards, so you have to think about
Oh,
it. You
of course.
get some experience with it. But this is my workbench in a mirror. And it's just a backdrop right now, a virtual backdrop. So the bench is the important thing. That was a wonderful acquisition from Mackie as they were tearing their company apart. It's like a $800 or $1,000 bench. It's all welded steel and with a heavy laminated top. I mean, it's pretty incredible. And then the top, the shelving, Howard did that for me. He cut all the pieces and I went and glued it all together and so on. So it's kind of that's kind of nice. That was all designed so that I could fit typical Tektronix, et cetera, equipment in the shelvings for maximum efficiency.
Oh boy. Yeah.
Right, and then of course the work surface is kind of free, although this is actually an older picture. It's since a lot of the stuff is filled up in the top and then the bottom section. So it's not quite, it's a little more cluttered now. Has a few more pieces of equipment, but essentially what's here is, of course, a work light. There's a high power supply for doing amplifier work. It's got bipolar outputs. And then over here, there's a low power supply, goes up to 30 plus or minus 32 volts. So that's for, doing work with low level stuff. There's a Variac. Actually now I have there's an outlet above under the shelf so that I can power stuff from the Variac. And then up here, there's a RMS watt meter, which is another salvage from Mackie. $1,200 piece of equipment that I got for $50 or something. A lot of good stuff. So you can actually look at watts and current, consumption from whatever the Variac is putting out. So you can see the amplifier efficiency measurements, etc. Now there's a 5.5 digit Fluke, multimeter there with 4-wire ohms capability, so I can measure, a milliohm easily. There's my old faithful Tektronix 2-channel, 16 megahertz analog scope. Got a very nice trace. And then there's a bunch of tech, what they call the 500 series rack equipment. There's a harmonic, an THD and IM analyzer, oscillator with balanced outputs. I think I have a couple of those. There's some a filter set, analog filter that allows me to adjust the high pass and low pass filtering if I want to look at, narrow band noise measurements. So on. So there's a bunch of stuff. There's a current probe. There's another couple other little power supplies in there. Up on the top, there's a Kronheit oscillator, which is a great gadget. I used we were using it back in the DBX days, but they go from 10 hertz to 10 megahertz, put out 10 volts from 50 ohms. So you can drive a lot of stuff with that.
Wow.
And it's nice for looking at, checking wide bandwidth, etc. That's just another analog scope up there. There's a Hewlett Packard old 400 series AC DTVM that has a 4 megahertz bandwidth. So, when it goes down to a millivolt. So when you're measuring, wideband stuff. I think there's a counter timer up here. A couple of other things. Of course, parts cabinets. Anyway, yeah, there's a few more pieces of equipment in there now, but mostly what's happened with the back of the bench along here, where it used to be the workspaces, it's kind of like filling up with little project pieces and little trays full of stuff and so on. So that's what
But you've got about 2 or 3 more of these workstations, don't you?
I have a couple out in the garage.
Yeah.
Right now, they're just storage units. I mean, there's so much stuff piled up there now, old prototypes of things, Gus, that I built. Stuff that's in the process of being taken apart, for parts, to resalvage the parts. I mean, anyway, this is kind of nice. There's, if you see this bench came with a nice set of drawers, which is quite handy if you don't bump your knee on them. Okay, and then over to the far end there, you can just see tucking in the corner. There's a set of 4 drawers that come from IKEA. That's a really good deal, and that holds a bunch of probes and tools and wire and other things that I use on a fairly frequent basis. What else do we have? I think since this picture was taken, I also got from Mackie a nice big arm with a magnifying lens and lighting and so on. So that's quite handy for looking closely when you're doing surface mount solder work. So yeah, I think.
Cool.
So anyway, a lot of this is old equipment. I'm an old analog engineer, so we were talking about interesting just the other day. Sean sent me a picture. He just recently bought himself a nice workbench like this. Spent some money. He said, "I'm tired of working, doing soldering in he was doing some kind of tea trays or something like that on his kitchen stove, right?" So he finally bought himself a workbench and set it up in his downstairs room. And then he said, "I need some equipment, so he needed an LCR meter. So I went on eBay, found a $25, $35 meter, and I found some $150 and $200 meters. Of course, he bought the expensive one, but it had the advantage that it could test that capacitors, inductors at different frequencies. So if you want to look at how a capacitor behaves, you test it at low frequency, and then you test it at high frequency. You can see whether the capacitance is the same, what the dissipation factor is with different frequencies, and so on. So he got the LCR meter. He said, "I need a scope," and I said, "Well." I said, "That's a whole nother thing." I said, "You have to think about what scope do you need?" I said, "There's no point in you buying an old analog scope when you can go and buy, even a virtual scope, right? If you got a laptop there, you can just get some devices that plug in via USB, and then you can do all kinds of DSP on your waveforms and so on. So probably you want to think about buying a newer, digitally based scope. It does basically conversion. If you only need audio bandwidth, you can get some stuff that has pretty decent, like 16-bit or better resolution. I like Dana. I mean, he just got a sound card, right? You got a 16-bit sound card. You can do an amazing number of things with that, and that in a laptop. So we're trying to figure out what it is that Sean needs next, but he doesn't need this. He doesn't need all this setup.
Neat. Thanks. Wow.
Thanks a lot.
Yeah. Anyway, that's the short tour.
Yeah.
Great.
So Max, I heard rumors that you've started on monoblock.
Yeah. Well, we are contemplating. So I was asking Rene about the input and driver stage, what to do with the monoblocks, whether we use the same thing as the stereo or something different. I think we're going to go something similar. So that's what we decided. I didn't start routing yet, but I think soon I'm going to start the routing of the top plates and replicate what I did with the stereo in the mono version. So
Yeah.
gonna be a lot of work. I got most of the parts, just a matter of putting them together. Maybe a couple of other extra parts like, you know, hex spread diodes and stuff like that. But most caps and everything else, I got most of everything. Lucky that when I bought the parts, actually what like you all probably do, when you buy parts, instead of buying 5, if you buy like 20, it becomes more cost effective. And also at the same time, if something goes wrong with your part, you have a backup. So I end up getting extras, and now I have most everything.
Then you need those parts cabinets.
Yeah, actually that's the challenge that I had. And because all the resistors that I bought, there are like multiple values of them and all that stuff. It's a pain to really store those resistors with a nice, you know, because there are so many values and it doesn't fit into what you got up there. In each box, you need to provide multiple subdivisions. What I did actually, I took a photo album thing with some pockets in it. And I used the original resistor ESD packages that came in them, right? So I actually labeled them and I put them into the photo album. So with that, I can actually flip through the pages, and then I can locate exactly the resistor value that I'm looking for. And then, and I also have a database on my laptop, so I can actually just search and find quantities and all that stuff. If I need like 20 of something, I look up, and if I don't have it, and I order the same thing, I'll put in my order list. So next page that I ordered, I bucket them together. So save shipping and stuff. But yeah, overall, I think I don't know when. So once we have the input stage and all that, I think Rene, I don't think I need to have the input stage necessarily for drilling. We identify the number of tubes we're going to use for the input stage, I think. So I can leave the middle section open like we did last time, and I can drill the power tubes. 40,
Right.
41-inch drilling to do on a 3/8 of an inch aluminum plate. So I got lots of routing to do.
A 1-inch plate?
3/8 of an inch.
Oh,
3/8 of an inch plate. So yeah, it is. Yeah, I'm using the router bits, wood routing bits for them. So I can show you what I use actually. Let me just a second. I'll bring it up.
Yeah.
Yeah, they're elaborate. Just they're routed. They're underneath. They're routed for a larger hole because the sockets mount up from underneath, and then the screws are blind tapped into the aluminum. So from the top, it just looks like a nice flat aluminum finish.
that's a real nice deal if you can do it. I mean, most guys don't have the patience, but
It's a lot of work.
Oh, can you?
There's the router.
Sure. Can you see it? I'm not sure.
yeah.
So this is a 1-inch. Sorry, what is this one? Just a second. This is 1 1/4 inch bottom drill bit, bottom clearing drill bit. So it's a wood drill bit. But what I do is first on the 3/8 of an inch aluminum, I scribe the tube socket holes. And I also have to recess it with a larger bit like this one. So I first basically need to drill 1 inch, 1 1/4 inch drill for the tube socket to fit in there.
Yeah.
Since 3/8 of an inch thick, and I actually mount the tube sockets from underneath, they don't reach the top surface. So with this one, I recess them from the top. So when you take a look from the top, you don't see any drill holes and stuff. And I tap from the underneath, and I attach the tube sockets from underneath. So you don't see any screws at the top. Everything is actually tapped and mounted from underneath. So it takes some time, but it looks clean. So with this one, basically you just drill, you mark the holes. It's just working with wood, not much of a difference. You have to be careful, make sure everything is tightly secured and all, but I use the normal drill bits and the routing bits like these to just machine the aluminum. And then lots of WD-40 because it needs some lubrication and cooling. And you'd go slowly. So with the plunge router. First, I drill the holes and I knock them out because this drill bit, this router bit cannot go through the aluminum all at once. But if you have the center hole already open mostly, with this one, I shave off the edges and then it just makes a nice clean cut, clean hole. After I clean hole, then I use this bit because I scribe basically a small circle and a larger circle. And then with this one, I eyeball it and then recess it. So
Wow.
that the tube goes in a recessed socket that way on the aluminum. So these are the ones that I use. And then I have additional tap bits like these. So these are, they come in different sizes. So I have a, you know, like, I'm not sure if you can see it, but let me see if I can see myself.
Yeah.
Yep.
Yeah, we
Yeah.
can see it.
So these are the tap bits like this, and they come like a bottom tap versus flute or you know, more tapered version. And I kind of like this tapping tool actually the best because with this one I can really tighten it. There are two different kinds. One of them is like a, if you buy tapping tools, if you need to buy something like this, look for the hex or something like this. So because with this one you can really tighten it with a wrench. The other ones get loose and they're kind of pain to use, but this one is pretty handy for drilling very small tap holes using the bits like this. And you have to be careful, go slowly. I haven't done this before. I just learned as I go. And then, but now I can tap without any issue, any kind of hole, no problem. Once you get a sense for it, it's kind of easy.
Just
So
don't
that's-
break the tap in the blind hole.
Oh, that's I did that a couple times. Oh, this is such a pain. I just gave up. Some of them, if the bit is actually just sticking out just a little bit, using those hard, you know, the locking pliers, you can actually lock on it and then just turn it. But if there's no extension, then you just forget that hole and drill another one next to it and shift it or whatever. It was twice. Well, I tapped probably more than 100, maybe 150 holes. And
Wow.
right now I can tap anything, anytime, and anywhere that I want. But initially I broke two. One of them I was able to get out. The other one is there. So.
Wow.
And Max, when you were using your router with the that flat bottom bit and making the holes in the aluminum, what did you do to secure your router and to aim it so that you knew?
Oh yeah.
I guess I could figure out how you would, if you described it, you could locate it, but how did you get it so it wouldn't wander?
Yeah. So I built a jig. So the router actually has holes under it has a router plate, right? Like this.
Yeah.
It's not an undermount. It's actually from the top. There are holes, guide rail holes on the router
Oh, okay, right.
base. So I bought, I forgot the size, but maybe 3/8 of an inch or 1/2 inch, whatever the size fits into those guide rails. I bought aluminum rods, you know, circular aluminum rods, and I attached them using the router, those tools that you know, the tabletops and stuff, you know, for the carpentry. You can use those knobs and stuff to attach equipment in your tabletop, saw and stuff.
Right.
So I use them. I built a jig on the edges, and I actually just mounted that to the table in the garage. And using those, I actually fixed the router base using those rods across.
Okay.
And then it's and I can locate the router this way, right? And then I can also move the jig the other way. So I have two-dimensional freedom.
Wow.
I can locate exactly where I want. And then when I'm in the spot, I tighten the knobs so the router stays fixed in that spot.
Okay.
There is a bit of a give still, but as long as you're careful and you're not really just going so fast, but slowly, then it actually stays on the spot.
Are you using a plunge router?
Plunge router, yeah.
Oh, okay.
Without plunge router, this wouldn't work.
Right.
You need to have a plunge router for aluminum.
Is
Yeah.
your sense of those router bits that they would work in a drill press? If you put it like on high speed in the drill press?
Yeah, I think so. I think so. Yeah, I bought a drill press also from Harbor Freight at one of those places. But later on, I found out that with the drill press, what's important is the distance
Oh.
from the shaft where the
Right.
drill press actually attaches,
Right.
and your piece, right? So the hole. So in my case, it's actually small. I figured out it's an 8-inch or 10-inch, I think. So with that one, I cannot have the whole 18-inch go there and then drill something in the middle of it. But if you have enough freedom for your drill press, I think you can use these things for them. But the ones that I got are pretty heavy duty. These are 1/2-inch shaft on them.
Yeah. Yeah.
Wow.
But they also have like a 1/4-inch shaft too, like this one, for example, for a different kind of drill.
That's pretty dangerous, isn't it, if you're using big bits?
Not really, because it is very. I mean, you mean these things are dangerous?
Yeah.
No, this is actually for the router that I got. It is very, very stable. When I put this on the router,
Right.
it stays very securely in place, and I had no issues with them. These. I like these actually better than the little ones.
Yeah.
Little ones are more pain to work with, especially with aluminum. But these are actually very nice. So this one over here, for example, this is a 5/8. So bottom clearing also.
Yeah.
But you don't use these to drill through aluminum. First, again, you need to, using a drill it out, empty out a socket hole or something, almost all of it. And then with this one, you just clean it out. So that's the way to do it.
Wow.
And other things that I found with the aluminum is you can get those for the chamfered and stuff, like edges. When you cut them, they're kind of sharp.
Right.
So then you can use chamfered bits, like this one, for example. Okay, so with this one, as long as you center it nicely, you can actually go and clear the edge of the hole that you cut. Just a little bit, just to chamfer it if you want.
Yeah.
Anyways, I learned a lot with the aluminum, but it's easy to do. You shouldn't be afraid of using it. If you're comfortable with wood bits, it's easy. The only problem with aluminum, it makes lots of mess, and it's metal everywhere. And I have a shop vac, and I just use the shop vac just to vacuum everything out. But it makes a lot of sharp aluminum shavings all over the place. So
Yeah.
but yeah, amplifier build is pretty nice. I don't know, the monoblock, I'm excited about it. The stereo version that I built actually is surprisingly very, very powerful. I mean, it's not like 600 watt the solid state amp that I have, but it is enough driving the speakers just fine. I was really surprised about it. It might depend on the speakers. Dana and the Howard, as you're building speakers, one thing that I also found out is that if you can actually keep the speaker impedance higher instead of 8, if you maybe try that yourself, try the 16 ohm. If you can actually design for 16 ohm nominal impedance, I found that the amplifier that I built actually works better with those kind of speakers. Higher the impedance, the better. That also explains the good bass frequency response that I get, because the speaker that I have goes down to about 32 ohm for the bass.
Mm-hmm.
But for the 20K, it goes about 2 ohm, 2.5 ohm, something like that. And it's a pretty linear change in the impedance range for the frequency, but with the bass and mid-range, it is effortless because of the impedance, I think. So
Yeah.
something to keep in mind.
Right. Yeah. So you did some LT Spice modeling, I think Renee was saying.
Yeah. So I basically modeled the entire amplifier into LT Spice, the whole, the one channel of it.
Right.
And surprisingly, it actually matches the real data. I mean, it is very, very close. When I change, for example, a resistor value, or with Rene, we were contemplating some resistor values here and there, and I plug into the model, and I can see where the cutoff is going to happen. For example, we put a diode in some locations. I put that diode, and if I actually keep a diode value like 5-volt diode, I see that it clips before it reaches a certain value on the gain stage. If I change the diode with 14-volt diode, it opens up, but it still clips at the maximum power. So by just playing with the different models for the different diodes, I found out that the best value was about 16 to 17-volt diode. And Rene confirmed it too, kind of surprisingly, because we were looking at the tube charts and all that, and said, well, you should use 16 or 17. And LT Spice confirms that too. So, which is good, good to do. So, because I haven't used LT Spice, I'm not really proficient in it in any way, but with the model that I built, it works okay. And I modeled the same actually thing for the monoblock now, using we doubled up the input tubes, doubled up the driver tubes, and entered the LT Spice. I saw some issues, but I can observe 45-volt output. So with 45-volt output, basically per channel, with the doubling up of everything, I get probably equivalent of 220 watts onto 8-ohm load.
Wow. Yeah.
Which is similar to what Atmosphere MA2, which is, mine is kind of like a clone of that.
Right.
So I'm getting what they're getting, at least on the LT Spice, but we'll see what it turns out with the.
That's very exciting.
Stage, Rene is gonna help me with. So.
Well, I'm a huge fan of LT Spice. I will.
Oh, let's see.
I'll quickly share my latest LT spicing. Let's see if I do this, if it will.
I like the second one best.
Yeah. So let's see which one was I running here? If I confuse myself. Okay, so those ones I did not run. So these were just variations on a little amplifier. So I started off with this one here. And so I bought this transistor from, oh my gosh, who's the guy that does the, oh man, the Zen amplifier. So,
Nelson Pass.
Yeah, Nelson Pass. So, I was looking at that Zen amplifier, the first one, gosh, back in like 1998 or something. And so I bought the parts, and all he had was, he had a big MOSFET and a couple other parts, and then it sat around here for a long time. And then I thought, oh, I should model it in LT Spice. And I played with that, and then I thought, well, why don't I put an op amp in here? Just totally ruin his design. So I did that. I put this op amp in here and put massive feedback in there. But the thing I discovered, which was kind of fun, is so LT Spice, if you guys don't know, is free. So you can just download it. It was by Linear Technology. I think now Analog Devices owns it.
Right.
Yeah.
You're Scandinavian, aren't you?
Yeah. And so you could just come in here and, you could say run. You click the little run button, and it simulates the circuit. And so I've got an oscillator in here running at 1 kilohertz, creating an input. These are power supply voltages, op amp, my MOSFET, and then I've got this 8-ohm load simulating my speaker. This is a transconductance amp, so I'm measuring the voltage across this 1-ohm resistor and feeding that back, so it's a current output amp. But the thing I learned recently was you can get a very precise answer using high precision math. So there's this option, number of digits 15, and so if you do that, add that, it creates very precise calculations. And so then when you do this sine wave simulation here, this is the output current from the amplifier. You go in and you just say, oh, I want to look at the, oh, I messed it up. I run it again. It runs. When it's running, you come click on whatever you want to see happen. There it is. So you can look at the current in any part or the voltage, and it'll plot it. But let's see. So we want this current, IR7. Then there's a view option up here. When you're looking at the plot, it's a little tricky. If you've got, depending on which window you've got highlighted, this menu up here will change. And so you see when I clicked on the plot, now it's got some different, so up here under view, you can say FFT. And then you pick which signal, it highlights the one we have plotted already. And when I click this, and you can change, so I'm doing a big long FFT here. And you can set different things in here, but anyway, the defaults I've got. And so there is the FFT of that 1 kilohertz sine wave. And so what's dramatic here is that the simulation noise is so low. Actually, if you just plot the output of the oscillator, it's down like 100 and, or no, it's down like 280 dB. If I was just plotted the oscillator, it would be up here, and then the noise floor would be down at 280 dB. So it can really, the math is done very precisely. But you can see here so here's my second harmonic distortion at 120 dB down. I'm not doing a full 0 dB. I'm at minus 10. So I'm 110 dB down, my second harmonic distortion for this amplifier.
Wow.
So it's amazing. You can do these simulations and actually see very fine detail, and provided your models are good. I haven't actually gone and measured it, but by tweaking this amplifier, I actually got the second harmonic down so that it was 130 dB below the fundamental. But anyway, so I have yet to go and measure that, but yeah, so that's kind of fun.
Hey, Dana, how did you get to that again? Can you show me again this? Because I didn't find a way to get the THD measurement. There's like an error log. I was searching and it shows error log. You can check error log. It's kind of confusing and it doesn't show the real data.
That was what I was doing for years. I just learned this like a month ago.
This is cool, actually. So you just go FFT or what is it?
Yeah, so what I did, so this is the transient simulation. So, you know, I assume maybe you're doing that.
Yeah, I do this run thing. Yep.
Yeah, and so under the because I'm in the wrong window. But so yeah, so under simulate, of course, you do the simulation command, you do transient.
Yep.
And I did a very small time step, 0.1 microseconds.
Okay.
So that's kind of the key. And then I did 20 milliseconds, so I get a number of waves at 1 kilohertz. I'm getting 20 of them. And then, so this is key to getting the very low noise floor. You could do a shorter one, and you could do, you know, 1 microsecond, but then you won't get the really low noise floor.
Yeah.
But this was key. And then then you run it, and then it goes slowly, because it's doing the very fine time steps.
Yep.
And then when I highlight, so I just clicked on that plot window, so that it's the whatever the. And then up here in view, there's FFT.
I see.
And then you pick which thing you want to FFT. And
nice.
So if I pick V3, which is my oscillator, it's not going to tell me. That's not the node name. So there's a trick to this. You got to know your node names. So that's VN. I clicked on it and plotted it up there. So that's VN07. It's just to show you how quiet the oscillator is. So if you double click on it, it gets rid of all the other plots. Each time you click, it adds another plot. So you can see the signal levels at different spots in the amplifier, you know, by each time you click. And then if I double click, it will remove all those other ones. Now I just have the output of the oscillator. And then we go up here and we click on the plot window. Now it's whatever.
Yeah.
And then view FFT. It's already highlighted V. You could pick a lot of them.
I see.
And there you go. So this shows you how quiet the oscillator is.
Wow.
Wow.
I see.
So can you even imagine?
Wow.
That's ridiculous. So it's a mathematical oscillator. It's got harmonics that are, you know, minus 230 dB. It's crazy. So anyway, so just needless to say, you can make a very quiet virtual oscillator. So anyway, yeah.
Is that sunspot noise up there around 1 megahertz?
Probably, yeah.
Oh, okay.
So that's my one transistor plus an op amp amplifier that I've been playing with. Yeah.
That's cool. And
That's very cool.
one thing that I found also, and you can maybe show it over there, the frequency response, right?
Oh,
So you can-
yeah.
You can show the frequency response too.
Let's do that while we're in
And-
here.
That was also, well, with my amplifier, it was close. It was showing a bit better on the simulator than the real life.
Yeah. So there's different simulations you do. So you go into, so I've highlighted the schematic.
Sorry,
There you
you're
go.
not seeing it, I think.
Oh, I'm not sharing. Okay, sorry. Thank you for pointing that out before I got too far. What happened? I got to get back to the other window. There it is. And then I got to go share screen. Okay, now you see it?
Yeah.
Excellent. So there's different kinds of simulations you can run. So I've highlighted the window with the schematic in it, and you go simulate, edit simulation command, and then there's AC analysis. Is that what we want? Yes.
Yep.
And this is the new version, and it's a little bit dorked up. It doesn't remember these settings. So you have to come in here and put the darn settings in every time. It makes me nuts. I got to go back and use my old one. And so then you pick your number of points per octave. Start frequency will do like 1 hertz. Stop frequency will do 100 kilohertz. Probably good. Okay. And so what this does is it builds this little text command. And then we hit the little guy running. And now I have to pick, let's see, we want to look at the output. There it is.
Yep.
So, scale the window a little bit so I can see it. There we go.
Wow.
And so is there a grid? Add traces. Not sure why I don't get a grid. This new version just kind of done a little bit. But anyway, so you can see that it's flat. This is
Well, I guess so.
so this this trace here, I don't know if you can see my cursor or not, but the lower trace is the frequency the amplitude response.
Mhm.
So you can see it's down whatever, just because I don't know what 0 dB would be a volt or anyway. Oh, this is in current. Oh no, it's a voltage. I picked the voltage. You can do voltage, you can do current. Here's the current response.
Voltage at the top was like all flat though. I mean, if you, yeah.
There we go.
Yeah, okay, there you go.
Oh, wow.
Yeah, so you can see it's a flat frequency response out. It's down a few dB. Let's see. Oh gosh, yeah. Well, here's 3 dB down is the bottom line. So it's down 3 dB at a megahertz.
Pretty good.
And then the phase response. So this is the phase angle. So yeah, you can see it. Yeah, we get whatever. It's 90 degrees out here at. So yeah, at 100 kilohertz, we've got 16 degrees or something. At 20 kilohertz, we've got a few degrees. So anyway, very flat.
Oh,
Yeah, so it's a nice, simple little amplifier you can build. So I've got one built over here. I think I showed it last time, but anyway, yeah. So that's kind of neat. And so you can go and you can look at the response at different spots. So like there's if I click on the oscillator output, so you can see the oscillator, of course, is flat forever. And then we can look at what does it look like coming out of the op amp. Also, the op amp actually has some roll off in it. Yeah. You can look at the frequency response going through this resistor. So yeah, it's because it's a what a capacitive load. There is the input to that. It's got some things happening, and then the feedback loop. Of course, we can look at what's going through the feedback loop. So that's the current going through that resistor plotted. Anyway, so yeah, it's so nice because you can just see any signal you want by just clicking on it. And then yeah, if you build it, you can go in there and poke at it with your voltmeter or your scope or whatever. But yeah,
That's a cool tool. Yeah, a lot of things you can do with it, and it's as good as your models, though. In the end, right? All the
right, yeah. So
whatever you can find or build yourself, I guess.
Yeah, there are thick books on creating models, and I bought a couple of them. And the models are quite good, like from Linear Technology. So that op amp is a Linear Technology op amp, and so the model for that is very good. And then I created, I think I may have created. No, anyway, the MOSFET model was already in there, I think. But yeah.
What the amplifier you built, is it a mono amp or stereo amp?
Oh, it's
It's disappeared. Oh no.
it is a mono amp. So this is actually it.
Wow. Yeah.
And can it drive speakers?
Yeah, so it drives a speaker. So you can see I just have my op amp sitting on this proto board, and there's my transistor. I'm just mounted in a big old heatsink, and nothing's even mounted. But so it's the circuit board in the background. I just used because it had the proto board on it. So I'm not using any of this other stuff. So I just have the op amp, a couple capacitors, 2 or 3 resistors, and then so the whole thing's whatever, the 8 parts you saw. And this is a Cypress Semiconductor demo board for this processor, but it came with this prototyping board. So so yeah. But,
and that's a current drive amplifier.
It is, yeah. The way I could configure it either, just depending on how I set that feedback connection. But yeah, so the way it's configured now, it's current. It's a
Hey, Dana?
Yes.
Yeah, when you put that together and you put that board on there, what did you do? Did you just hook it up and then start cutting wires off until finally the signal changed, or how did you do that?
Well, I did it all in Spice first.
Yeah.
And then I just replicated the circuit there, and yeah, that circuit, you just plug the parts in and strip the ends of the wires, plug them in there, and hook it up. So there's only 5 solder connections, so it makes it really, really simple.
So what do you use that for? Have you driven anything with it? Headphones?
Yeah. Actually, at the last meeting, I was playing my little LS35A with it. So it puts out, I don't know, you can probably get, I guess if I had the power supplies right, you could probably get 10 watts, 15 watts, something like that. So it depends on, right now I only have a small load resistor, so I can play it for a few minutes at plus or minus 12 volts, and that resistor starts cooking.
Yeah, okay. Neat.
Yeah. So that's the opposite end of the scale of effort for an amplifier from what Max is doing. So Max over here, I'm way down here. No holes were drilled. No circuit boards were made.
Oh boy.
Yeah, the biggest effort was stripping the ends off a solid core wire and pushing it into that was the.
Oh boy. Oh, neat.
But yeah, if anybody wants to build one of those, I could send them the schematic. It's a relatively simple project. Of course, you could start with Nelson Pass's, his design too. If you want lots of distortion, you'll like that. Yeah.
Probably get some of the boards on DIY Audio Store. Yeah, you know that
Oh yeah, yeah.
for Nelson Pass and stuff.
But yeah. So, all right. What's anybody else got anything they want to talk about?
I just wanted to ask Renee a question.
Yeah.
So, Renee, do you use LT Spice?
I don't actually, although I have it here installed. I haven't actually.
So then, when you design your circuits, I mean, how amazing is that you design them? So you do all the math yourself then?
Yeah, a lot of it's really intuitive. After you've been doing this for 50 years, you sort of know.
He's got LT Spice built into his brain, I think.
Yeah, that's what I thought. Yeah,
But that can do, of course,
that's
you
pretty
look at the
amazing.
data
Amazing.
and you determine where you need to bias the tubes for the best operation. And actually, what I did with Max's is I have a breadboard in the other room. I guess I could. Well, I'd have to disconnect it. It's got about 15 wires connected to it, but with a couple of power supplies and a filament supply and all that. And what I've been trying to do recently is take the basic input circuit from Max's amplifier and try different tubes running different bias points. And that way just finding the outcome. And it's amazing how much difference there is between different brands of tubes. I mean, I have a lot of old stock 6SN7s, so I was able to plug in a number of different tubes. And there is a lot of difference between the tubes from different manufacturers, and also between individual tubes from a given manufacturer. So I've selected a half a dozen good performing tubes for Max. I'll bring them to him later this week, and he can plug them into his existing amplifier and see if he likes the sound. But they were chosen for actually better distortion performance. And in Max's OTL amplifier, although there's only one major gain stage, the driver stage is a cathode follower, and on the output stage is a cathode follower synchrotron circuit. So it has a gain of about 0.5. So you need to get all of your voltage swing in that one input stage, and it's considerable. It's like 200 volts peak to peak swing, out of each plate. So there's a bit of optimization, but if you pick the right bias points, you get pretty decent distortion. I'm talking about under 1% with 200 volts peak to peak output. So with the right tubes. Some tubes are really horrible. I mean, it's amazing how bad they can be. So yeah, there's no guarantees with vacuum tubes. That's why it's important to look at each one individually. So that's what I've been finding. But I find just working with the physical breadboard is quite easy.
And then measuring it yourself. Yeah.
So Max is running this thing with no feedback. We played around with different levels of feedback on his stereo prototype, and he prefers it with no feedback. So it's essentially, this is the current output amplifier. I think it has a damping factor of what? About less than 1, right?
Yeah.
I think the output impedance is quite high. I don't know. I calculated at one point, but it's fairly high. But it sounds good with the electrostatics for some reason, even though it's got this variable load. So what he has essentially, I think, is a frequency response that's kind of sloping downhill at higher frequencies. But so he likes the way it sounds. I mean, he says one thing is that the sound is more live, more open when you don't have any feedback.
Yeah.
So there's still some contention about whether feedback is good or not. But as I point out, and other people, including some famous people on the web, if you use a little bit of feedback, you increase the higher order harmonic distortions. Okay, and that's probably what makes it sound not as good. If you use a lot of feedback, so the distortion is at an incredibly low level, maybe that's okay. But in his case, we're not going to be able to get a lot of feedback because we can't, out of a single stage amplifier, we're just not going to get enough gain to apply any reasonable amount of feedback. I mean, if we work hard, we could probably get 15 dB, which is not a lot of feedback. So, so anyway, so what I've been doing anyway basically. It's just the physical playing around and selecting
Yeah.
vacuum tubes, which if you've got a big stock of old vacuum tubes, I guess that helps.
What
Feedback.
makes a difference for the, you mentioned lots of variance across the manufacturers, even within the same manufacturer tubes and all that. The thing is, I have a tube tester and I use that to assess roughly the match between the two triodes. And I try to pick the ones that actually close the match as much as possible. What additional things we should look into in terms of selecting a tube? Because I won't be able to see the noise level directly using the tube tester because it doesn't tell me that. What kind of things do you do to measure the tube noise? Is it your THD analyzer and stuff that you use for that, or?
Well, the tube tester is only going to measure the tube at one particular point, and it's not, they're usually not measuring them at a place where you would normally run the tube. I mean, the tube testers are fairly simple-minded. I think yours measures transconductance, just as mine does. I have an old Hickok, and it measures transconductance, but it does it with a, it puts in a 60 hertz sine wave off the line transformer. So of course, there's no way they're going to measure distortion because the power line has probably 10 or 15% distortion if you look at it. So they don't measure distortion; they measure transconductance, and it's done as an increment at a given bias point. Now, what happens is, well, how does that transconductance change with bias? As you know, what makes the triode linear is if you look at the, as you remember from looking at the tube curves, the transconductance increases with increasing plate current. Okay. The plate resistance, on the other hand, decreases with increasing plate current. In a good tube like the 6SN7, they kind of cancel out, and what happens is the mu, which is the gain, is almost constant across that whole bias range, almost. Okay.
I see.
So distortion in a voltage output amplifier will really depend on how linear is mu with current through the tube. In other words, is that mu going to be constant from, let's say in your output, in your top tube, we're biasing it at about 1.5 milliamps, and that has to swing almost down to no current, all the way up to 2.5 or 3 milliamps. So, so the question is, what happens to the mu over that wide range? So if the transconductance and the plate resistance don't track, and apparently there's a lot of effects inside of a vacuum tube. So you have to remember the tube curves that are presented are an average over a large number of tubes that were built at that time. And if you take any tube from a different manufacturer made in a different era, there may be variations due to just the physical structure, the materials, etc. So you're only looking at an average set of curves. And so that's where I usually start. You start with the tube curves. You try to find the linear operating point. And then you put it in the circuit and you measure it. And then you move that operating point around and see whether, in fact, that's the best point. And it often isn't exactly the best point. What looks perfect on the tube curves isn't always the best place to run the tube. So, as I said, the tube tester isn't going to tell you anything. Match and transconductance is a good start. If you see the same, transconductance on both halves of both sections of the dual triode, that's a good place to start. But I found out that even with that, if we put a little, like I suggested, put a little balance pot in the cathodes and this is a differential pair between the cathodes, so we can vary the balance between the two sides. You can still optimize by changing that a little bit from the both cathodes operating at current. You can optimize the distortion. You can look at the distortion out on the distortion analyzer, look at the distortion residual, and you can adjust that pot, and you can see how the distortion changes as you balance or off balance the tube. And for instance, one of the things I found was is we could actually adjust the distortion. We could adjust the balance of the tubes off so that we get dominantly second harmonic distortion, even though it's a push-pull stage. Okay.
I see.
But if you tune for minimum distortion, it's only third harmonic. You see only third harmonic appears. You've nulled out all the seconds, and so you just see third harmonic with the perfect balance. So anyway,
wow.
Playing with the perfect balance may not be essential. If we put the adjustment in the cathodes, we can take tubes that are slightly unbalanced and still tune them for minimum distortion.
I see. Oh, this is different than the balance on the cathodes then. Maybe I misunderstood. For the driver cathodes, we still need balance there. This is just for the input balance. Or is it the same?
But we're assuming your input is balanced. I mean, you're driving from a balanced source.
Oh, no, what I meant was, remember on the output, between the output driver cathodes,
Oh.
we have a balance too, right? For the DC offset.
Oh, that's just, oh, well.
It stays there, right?
Well,
I think that's a different thing.
Balance because that's because that's what you want to do. You want to balance the output tube so that you have 0 volts
Yep.
nominally across the load. DC.
Yeah,
That's what that balance just the bias on the
on the output, I see.
both have the same current flow. In
I
a certain
see.
time, both having the same current flow results in no output voltage of the load. Okay,
I see.
all right, but that's not what we're talking about because that's not where the distortion comes in. The distortion comes in from the input stage.
I see.
We're talking about putting a pot in the cathodes of the input stage of the differential amplifier.
Yeah,
So
got
that
it.
we can balance, tune for minimum distortion if we want, or for second harmonic if we want.
Yeah,
Okay. And the other thing I suggested, of course, is we have a current source for the tail current on the differential pair, and we can put an adjustment in that too, which allows us to set the actual DC plate voltage of the upper tube, because we want to put that in the optimum range between its cathode voltage and its plate supply, where it actually generates least distortion for a large signal swing.
yeah.
In our case, we're going almost from rail to rail on the
Yeah,
output.
maximum, yeah.
We need to find that sweet spot, which we
Yeah.
determined already, from playing around on the first prototype, playing around with resistor biasing. But if we put it in the current source, we have the freedom to move it wherever
Adjust.
we want.
Yeah, that actually will help because the thing is, with the variance in the line voltage, the upper, in general, the tube plates voltages change, and they drag too. When I plug the amplifier, all the voltages go down. Even though in the idle they are fine, perfect, fine, but when it's working, it's actually losing about 20 to 30 volts on the output plates.
Of course you want to tune it under operating conditions.
With this one, yeah.
That's the other thing. We talked about possibly doing power supply regulation and all that, but it's probably not important.
Not important, yeah.
Distortion in the amplifier, the majority of distortion is created in the output tubes themselves, because you're operating over a really wide current range. So they're biased class AB to begin with, and then of course you ask the cathodes to deliver huge amounts of current at maximum output. So there's a lot of distortion just in the output stage. But so even though we make the input stage really nice, you still have a lot contributed by the output stage. But then when you think about listening to music, you're mostly running at you're probably running the amplifier in the class A for most of the time, unless you're playing heavy rock.
Based on my measurements, actually it's almost like partial watt. I mean, it's not even a watt.
Right.
I mean, I'm taking a look at the output current change in draw and compared to the bias point, it is not moving much actually. So
yeah, so you're running the outputs in class A for most of the time. I mean, that's normal for a class AB amp that's biased. I should bias pretty heavily, like you're heavily biased class AB. So you're running in class A most of the time for most signals.
Well, if anybody is interested, there are different. I mean, you can scale this amplifier to different sizes and all that stuff. So if you're interested, let us know. It's pretty simple. I really enjoy building it. The model is very simple. And with René's help on the input stage, we got a pretty good sounding design. So, and I think some people actually using these amplifiers even in a smaller scale for headphones, like Dave and others who are building the headphone amplifiers. You probably heard the OTL headphone amplifiers. It might be a good thing to try. With the 1 or 2 of those output tubes, you can get pretty good headphone sound too. I heard. I never listened myself, but I heard about it.
I'm sure it'll be fine. There's a point to take though with the cyclotron circuit. you're going to have separate connections for both earpieces because the load has to be floating in the circuitron. So it's not optimum unless you have a headphone that's wired with the four-pin plug.
I
Dave
see.
has one.
Yeah.
The
Okay.
balance,
Yeah, right. So if you've got the thing on a 4-pin XLR, so you've got two separate loads, then the circuitron circuit will work fine. And yes, I think just one of those tubes, if you get up, above 32 ohms, it'll be fine for headphones. You'll have really good, it'll be very clean. So, although Dave's headphone amp now sounds pretty good. I don't know. He could build this just for the difference.
just for the fun. Yeah.
You would have a headphone amp without an output transformer. Right now, he has a headphone amp with a nice output transformer built by Bud. Of course, they're unobtainable, so. So you're not going to be able to duplicate what Dave has, but it sounds awfully good. That's great.
Yeah. Yeah, once I got rid of the hum that I was having, some of the wiring that I did internally, and then I found I had a lot of hum caused by my cable management in the room. So
Oh, wow.
once I got that figured out, boy, it cleaned it up, and it does sound really nice.
So what did you do? What was the cause of the problem? Because wiring is always an issue.
Well,
Wiring.
I left some of the wiring purposely long because I didn't know if I needed to change things around in there. So typically, what was it, from the transformer primary, shorten that up as much as you can and twist them.
Yep.
And there were a few other places I did the same thing to the output tubes, and the output transformers had a lot of extra wire length on there. So that once I had everything working properly, then we shortened the wires in there. And then the other thing that was unbeknownst to me was it a resistor or a capacitor, I think, that was attached to the output tube. I had a long wire lead running to it because I mounted it on the sidewall. And Renee's experience with it says mount it directly to the lug on the tube socket. And that made a lot of difference too. So
So
a little bit here and there.
So Dave found out, the thing about headphone amplifiers is there's sort of a lot of the challenges you have in a preamp, especially your phone preamp, because the headphone only takes a few millivolts to tens of millivolts for full output. And so you need to get that noise way down, whereas in a power amplifier, it's driving a loudspeaker, you can tolerate a millivolt of power line garbage, and headphone amp, microvolts. You've got to really have the noise down. So then all of the power supply wire, because remember, you've got all of the stuff in the rectifier circuits is generating all kinds of garbage. So all that wiring has to be tight, close to the transformer. You have to be very careful about where the bypass for the filter capacitors are. You have to be careful about where the grounding occurs in sequence along the whole circuit, even though it's a simple circuit. So, that's what you have to be careful about in design.
Apparently on a lot of those issues, I got lucky the first time I drilled the holes.
You did. You had a good layout, and it worked through. And you mounted the transformers at the right orientation relative to the power transformer, so they didn't pick up.
Wow.
Magnetic stuff from the power transformer, which is a good thing.
Keeping the signal path wiring separate from the input wiring, power wiring.
Yep.
That helps. I knew enough to do that from the starts.
Yeah, it was good. Anyway.
But in a kind of a small cramped space, it was difficult to do too much with it, but yeah, it worked out really good. I'm really happy with them.
Yeah. Well, I don't know if everybody knew, but when Dave took it to Gary Coe's March meeting, where they had the Head 5 people, and I think it came in like it was the second most amazing headphone amplifier in the display. And the one that everybody thought was the greatest was so complex. He sent me some pictures of this guy really, he bent over backwards to do this incredible stuff. You know, like, and Dave had this simple 1 2. Like everybody's like, wow, you know.
That must have been the purple lamp,
Yeah, the purple lamp. Yeah,
made out of a wooden case made from Purple Heart.
yeah, Purple Heart. Yeah, right. But
Very pretty.
it was very elaborate
Yeah.
implementation, you know, to get great sound. It was good sound, apparently. But anyway, Dave, everybody said it's really good. So, really great. And I just keep pushing Bud. I said, "You sure you didn't make some more of those output transformers?" He said, "I might have some around." He said, "I have to go and look. I don't know what they look like." And so he hasn't been up to it. I don't know. I keep bugging him because I said, if you can come up with a couple more pairs of those, I think you've got some sales. We'll see.
One thing that happened to me this past week could happen to anybody. It's became more and more apparent. It's very important to have power surge protection or some kind of protection on your electronics. Somebody ran into a power pole down the road from me last week, and there was a power surge, and the power went out here for about 30 seconds, and then it came back on right away. Well, I came out to the cave, and I've got that power conditioner strip has built-in protection in it. So all my good stuff was plugged into that, and very important. And there's a GFI switch or outlet here in my cave, and that got tripped. So I had to go reset that.
Wow.
And I had 2 items that were plugged into that GFI outlet. One was the modem, and the other one was the wireless router for my computer out here. And my internet I couldn't connect my internet. And 2 days later, the internet cable service technicians finally came out, and the router got fried. So, and it was not plugged into anything other than the GFI outlet, which tripped. But I think by the time the power surge came through that, whatever was plugged into it got fried anyway. But anyway, I was really happy about my audio electronics and my entertainment center plugged into the other better power strip.
Yeah.
So
All right.
better protection.
Yeah, we have our stuff plugged into a battery backup system, so that has isolation protection and so.
Yeah.
Why you power down? We lost power the other day for several hours. I don't know what happened. I think they just shut it off for some maintenance. They were digging up something in the street. So you never know.
Yeah.
Yeah. Well, yeah. When we started talking, I mentioned my blown up capacitor for my heat pump, and apparently that is what kills these. Is the power spikes on the power line. So I've thought about going in and wiring in a surge protector into my heat pump. Yeah.
Right.
Is there anything such as like a whole house over voltage protector?
Yeah.
I think you can get that implemented in your breaker box.
Right.
I think the electrician did that on some of the stuff we had here, the last time they were here, but still suffered from it this last time for sure.
Yeah. Well, they will wear out. They'll only take so many shots.
Oh, okay.
Yep.
Well, out in our area, whenever we have a heavy wind in November or January time, trees fall down all over the country up here, and we get power outage. Quite every year we get a couple of them like that, so if not more. So
It depends on what happens during that power outage, which lines get tangled.
Yeah.
If you get the high voltage across the ground, that's not too good.
Yeah.
The neutral lifted. So,
That'd be the Tesla effect, right?
There you go.
no, it's just brute power flowing on the wrong wire. Yeah.
Well, I have one other audio related thing. I have been working on Terry Olson's open baffle project. He brought his coax open baffle in that only goes down maybe 80 or 90 hertz, along with the 18-inch H-frame open baffle, and he wanted to integrate that into a full three-way. So I've been working on crossing that over down there, and this is the biggest coil I've ever
Wow.
dealt with. It's a 9 millihenry.
How thick is that?
Wow.
Turn it sideways.
Oh, not quite as thick as my head.
Wow.
It's about this. It's almost the size of a hockey puck.
Wow.
Wow.
The size
And
of
then-
my brain.
Yeah. So the low pass for this 18-inch takes this coil. I've got second order on it. Is this coil and a 200 plus microfarad capacitor, and then I'm using a high pass on the coax, and I'm down around 100 150 hertz range. So it also takes a very large, probably 100 to 150 microfarad cap on that. So yeah, it's some big stuff this time.
And
So-
the big inductor, right?
Pardon me?
I guess the large inductor in the low pass, in the case of the open baffle,
Uh-huh.
probably you don't need to have the really low series resistance because you're actually trying to raise the Q on the woofer. So having a small coil like that with a fairly high series resistance, what is the series resistance on that 9 millihenry coil?
Yeah. Well, it actually, that I measured the frequency response on that driver, and I'm cutting it back down there because it does have a pretty good extension up over 200.
Mhm.
And I'm not sure if it's from the open bath, the H-frame cavity, but there is some resonance ripple in there that's pretty significant, close to about 200 hertz. I'm trying to lower that down, and the 9 millihenry seemed to take care of that.
Yeah, but you don't mind it having a fairly high resistance because it just raises the Q on the driver. So it kind of
Oh,
boosts
okay.
up the bottom end a little bit,
okay.
right? Do you know what the DC resistance is on the coil?
The DC resistance on that 18-inch,
No,
or on this 9 millihenry.
It was probably spec when you got it, right?
Yeah, I believe it's about, oh,
Probably
shoot,
somewhere around an ohm.
yeah, it's about an ohm or more,
Yeah.
1.1 or 1.5 ohms. Yes.
Yeah.
Yeah, okay.
Yeah.
Right.
You know, actually, a high Q on an open baffle gives you base extension.
Mm-hmm, right.
And they usually can use it.
But I've hooked it up and I've listened to it and it seems to work. So I'm getting down in the low to mid 30s probably with
Wow.
it.
Well, that's good.
Yeah.
Is it one of those timpani drivers that came through Renee?
Terry?
How's that?
Is it one of those 18-inch timpani? I think that was the drivers that came through Renee from Mackie.
Yeah, yeah.
Okay, yeah. Mine was pretty tolerant of big coils. Yeah, that's what I ended up doing. Are you going to have some baffle step correction in there?
No.
Not at all?
Well, we've got enough. See, we're having to cut it back because the woofer is pretty efficient. So we can probably work that out without even having to do that.
Oh, okay.
Yeah.
Yeah, I found that the mid-range on my first open baffle was the thing that needed to be reduced quite a bit. And I think it's because it's, spewing mid-range out the back into the room as well as out into the front. So you're
Yeah.
basically getting what would it be, a 3 dB boost at least there? So, I mean, it's compared to having the same driver in a box. So, I don't know. All right, I had to pad down my mid-range a lot. The same's pretty much true on the surfboard one I'm doing now. The mid-range tends to get really hot.
Yeah.
Just curious what you guys were running into.
Yeah, the coax on this already goes down pretty good, down to somewhere below 100. So I'm trying to use that as much as I can. Yeah. And then, so the 18-inch, I've got to roll it off somewhere above 100 to blend in nicely with it. And I think I got, one thing that's interesting is I don't use it very often because if I got a 2-way or a 3-way speaker, I just cut the holes in a front baffle and they're all in the same plane. But with this, you've got this coax that's a separate unit mounting versus the H-frame below it mounted in its own mounting. And so you can easily use the feature in LSPCAD. You can shift the depth dimension of the voice or the acoustic center of the drivers. And so it was interesting when I got the crossover stuff set up in there and I was looking at the acoustic phase and trying to line things up. It was a very happy, pleasant moment to find that you could change the number for the inches of depth, and you can basically shift the coax unit in or out from you to get everything to line up acoustically better. So it was just
physically,
you change a capacitor to a different value and it would change by a couple inches, for instance.
Oh, so it's, but when you're talking about moving the coax unit, you're talking about physically moving it in relation.
Right.
Okay.
Yeah.
Okay.
Yeah. So I found that was kind of useful feature there for this one because they were mounted separately and you could physically distance them in their depth relative to the listening position. So.
Cool.
Do you know, Dave or Dana, how to figure out in inches in inches or centimeters or whatever displacement physically? I'm not saying this right, but say you change from a first order filter high passing to a tweeter to a second order filter, how much does it displace it physically and equivalent to displacing it physically in space? How do you calculate that compensation, or is there a calculator that does that, or where like my tweeter is physically ahead of my mid-range, and so I'm raising the order on the filter so that it will shift virtually shift the driver back, but I don't know how much.
Well, that depends on the frequency.
Yeah, I was going to say, it depends on the frequency, crossover frequency.
So at a given frequency, then how you do that calculation.
Well, there's a relationship between the frequency and the wavelength.
Okay.
Should be just multiply one by the other to get a constant speed of sound. So take 13,500 inches per second and divide that by your frequency in hertz, and that'll give you inches.
And then that would
correspond to the wavelength at that frequency
for a full cycle. Yeah, so that'd be
for a full
360 degrees.
Yeah.
So one additional order of crossover order, like from first to second, that would be 90 degrees.
Well, that gets you 45 degrees, I think, at the crossover point. I could be wrong, but I think it's fully 90 at the highest. Yeah, but I think at the crossover it's around 45. But yeah, you could look at it in whatever it is, BoxSim or no, what's the silly XSim, whatever the
yeah, probably XSim.
Yeah, they've got a distance you can assign to the driver. So you could just go in there and shift it back and forth and then look at the phase angle that happens. Yeah.
Well, look at the phase angle on the graph.
Yeah, so you could go in there and move it an inch and see what the change looks like, you know.
So theoretically, it would be, if it was a 90-degree, you'd take the time of one cycle and divide it by 4.
Yeah. Or what? Yeah, whatever the 360. Yeah. Yep.
Okay.
Yeah,
But I
but
think-
those numbers aren't precise though. That's another problem.
Yeah, I think
Yeah.
they're deal with ideal drivers that are well behaved and not jaggedy too.
Yeah, because they go all over the place. The best you can do is just try to align it right at the crossover point, because under that and over that, it changes dramatically sometimes. So you can, you never know where you're going to end up. So the best you can do is the exact crossover point and then hope for the best.
Yeah. So I mean, on the surfboard, the tweeter, it wasn't working out to mount the voice coils in line, and I couldn't even make like an angled line, which I could correct with a slanted baffle. So I was thinking, okay, well, it'd be nice to kind of roll the tweeter off at a steeper angle anyway, so it has a little less of a load around, 1500 hertz or whatever, because I don't want it, or in that lower range, because I don't want it to get overloaded. So I thought, okay, well, that would be convenient. Just raise the order on that driver, and that would shift the driver back virtually. But I didn't really know what kind of factors I was working with in terms of how much I was moving it by increasing the order. So I was just trying to get some kind of rough idea. But I think that what you guys are generally saying, that it's a little hard to tell exactly what's going to happen. Mm-hmm. So I'll try it and see how it goes. I think my whole speaker is going to be tilted back also, even though if I get the drivers pretty much in a line, I'm still going to have to tilt the baffle if I want alignment.
Yeah.
Yeah.
So I've
But
been-
Robert, have you been doing any tweaking on your open baffles?
Yes, I have. And I brought some stuff that kind of relates to what we just talked about. And they're like the 2 best tweaks I've done this year. So that's my share. And they're in like you guys are in graduate school, I'm in kindergarten compared to you. But here's one of the tweaks I did. My first decent turntable back in the 70s was an AR turntable.
Oh, yeah.
It was a suspended table, and that worked really well, that idea of having a suspended table. After that, I had a Technics that just sat on a shelf, and I didn't think it, even though it cost more, I thought it sounded worse. And then after that, I had a Soda turntable, Soda Sapphire, which had a suspension, and I like that table a lot too. So lately, about 3 or 4 years ago, I built my own turntable. It did not have a suspension, and it worked really well though. It was very solid, and I noticed that the more solid I got the table connected to the cabinet that it was in, the better it tracked. But then I decided I wanted to try and suspend it somehow. Now this is a very heavy table. So I started searching the internet for some sort of way of doing this. And I came on what I think is a really elegant design that didn't cost hundreds of dollars. It only cost me about $15. So what it is a piece of PCV pipe with some rubber bands around the edge of it. And you take, and this is kind of a joiner for 2 pieces of pipe.
Yeah.
Smaller dimension, the same kind of a joiner, and you stick it in here in the middle, and it's kind of self-centering, and you put the weight of the turntable on it, and you can put different thicknesses and numbers of rubber bands on it in order to change the resonant frequency. And I was able to tune it down to a nice low, like 7 hertz or something. And now I can pound on the cabinet and put my finger on the woofer, and the woofer doesn't move at all.
Nice.
So it's very effective. And the tracking is really good because it's very sturdy on the horizontal plane. It doesn't move around, just up and down. That tweak worked really well.
The SME turntable uses rubber bands, just
Does
like
it?
that. To
The only
suspend.
disadvantage I can think of is that rubber bands get older quicker than springs do. So I probably have to change these out every year just to keep them fresh, you know.
How long do rubber bands last around your house, Robert?
I don't know. I've never really measured them that amount of time, but I do come across ones in drawers that have had it, you know.
I replace a lot of rubber bands around here. They just turn on.
If you use red rubber bands, you get more warmth.
Up in the air.
Well, I guess blue ones for more high end. Yeah, who knows?
A little cooler sound.
Yeah, right. And what color do you use? That's right.
But that's great.
My second tweet
Nice idea.
is more to do with what we were just talking about. My open baffle speaker now, I have my mid-range and my woofer on the baffle, but my horn is on a separate platform. I wanted to decouple it from the baffle that the woofers were working on.
Yeah.
So it's on a big metal speaker stand. And you can move it in and out to align it with the rest of the stuff. So, you know, I had the same question you guys were just talking about, where you go on the XSIMS program and it has that offset thing. And one of the questions I have is, it's talking about this kind of offset, but the speaker's also offset vertically. So you really don't know what you're adjusting when you change that offset setting. And so I find that if you just take the speaker and move it around till you find the spot that you like, that's more effective than going by any set of numbers that that program's telling you. And so my tweak this week that I had was my horn rolls off a bit around 10K. It starts rolling off pretty severely, especially because I'm using a tube amp and everything. And so I, on several occasions, tried to add a tweeter on top, like a super tweeter, and it's not very effective. And Gary's done the same thing with his system, and you know, he'll put it in for a while, and then you get tired of it. You start hearing all the things that are wrong with it, right? And I think that's because that the idea of a super tweeter is why it doesn't work is because of the offset. The only way a super tweeter is going to work when you're crossing over at such a high frequency is if you could mount it exactly where the lower tweeter is. Because as soon as you start moving it, the wavelengths are so short, it's going to mess up everything. And it's those diffractions that what you're really hearing, even though they're really high, and you say, oh, it's added new sparkle. What you're really listening
Be out of phase real easily.
you're just losing stuff. So just out of curiosity last week, I decided I would put a rear firing tweeter behind the horn. And it was amazing, which is very surprising because the horn is directional, right? And I just put a regular tweeter behind this speaker, which is not supposed to be directional. And it just completely smoothed out all the high frequencies. Violins sounded way better than they ever had. It actually took some ringing out of the horn that I've always been working to get rid of and never could. And it was, all I did was put a small capacitor in series on the tweeter and stick it back there behind the horn. I didn't try to work out any special kind of crossover network, but it made a huge difference. And one of the curious things that happened was that I tried different tweeters and they all sounded incredibly different. Mm-hmm. So I had this is an old Morel 33 tweeter, which is a really nice tweeter.
Yeah, wow.
The 90s. It sounded horrible. that way. And then I had this this ribbon tweeter. This is a Foundtech ribbon tweeter. It sort of worked, right? And then let's see, where's the other one? I had?
Wow. 3/8 Mylar.
And then I went to this thing, which is the, or is this the? Yeah, this is the.
The PT2 or whatever.
Yeah, the Dayton.
Yeah.
This thing worked beautifully. Amazing.
I've always liked it. It's a good tweeter.
Yeah.
So I think the rear firing thing really works for some reason, better than trying to just add a super tweeter facing in the same direction.
You know what I wonder about, Robert, with that is that if you've got a dipole and it's with your dipole, you're putting, I guess, since you have a horn firing front tweeter, most of your, you could say what degree of what frequency range of output is going out the back, but it's unbalanced. It's not the full range if you've just got your tweeter firing forward.
Right.
Because on my open baffle, I ended up adding a little AMT on the back, one of those little mini AMTs on the back. And so basically you're getting all the sound out the back as well that way, or closer to it. Maybe it helps with filling out the depth of things, because the open baffles have a particular kind of relationship to the room, and they have a particular kind of imaging, and it's different than like a little monitor that's directionally controlled front firing box monitor. It's a very different type of imaging. I like it. Maybe having the full range of frequencies back there, you know, makes more sense to your brain.
Yeah, it's kind of strange that it had an unexpected result, in that I expected the soundstage to get bigger.
Uh-huh.
It didn't get bigger. It stayed the same. It was already pretty big.
Uh-huh.
So it didn't make that bigger. But what it did do was it focused the center channel.
Yeah.
It was much more detail without being offensive, and you could kind of see into that center image where people would kind of float out in front of the speakers, whereas before the center image was split out. So it had the opposite effect in that regard that I expected.
That's kind of interesting, because all the open baffles have the same design pretty much, right? So you have, interesting point you brought up, Robert. Basically, the mid-range and the bass drivers are open in the back, which means the sound radiates to the back and forward in a push-pull manner.
Right.
But when you use the tweeter or horn driver, there's no back radiation at all. And all the open baffles have the same designs and same probably issue that you observed. If you have the same mimic, basically you mimicked what the Magnepen is doing, or in general electrostatic speakers are doing. They have a full range going to the back and forward. So interesting. So that makes sense. I mean, you're basically doing the dipole in a open baffle, which the open baffles are trying to do the dipole design anyways, as a, you know.
And what Howard was saying about just part of what you're saying about just part of the speaker being a dipole. So I used to have my very first real hi-fi speaker was a pair of ESS Heil transmission lines. Mm-hmm. And the Heil tweeter is open to the back. But of course, the 10-inch driver and the transmission line only radiated to the front. And whenever I plugged up the back of the Heil, I dampened the back, it sounded better. So that's the way I ran it. So that would support this idea of only part of the speaker doing this push-pull effect in the room, not working.
That's interesting. Because the thing is, I noticed that with my electrostatics, if I go to the exact back of, mine is curved. Oh. So if I go to the back of it, the exact center of it, and it's different distance from the center, the sound focuses at a certain point, like you're saying. So if if there's a reflection from the back wall or through the wall coming back to you from the back in a focused manner, I think that helps with focusing the sound right in the center. Yeah, interesting. Because I mean, I observed that with the electrostatic speaker, the same thing that you do with your open baffles, the same behavior actually. And if I cover the back, all of a sudden the sound changes completely. If I cover the part of the speaker in the back, the sound changes also different. Well, it's all reflection of sound all through the room, I guess, that you perceive.
Yeah. Yeah. So those are my 2 tweets, or my 2, yeah.
Yeah.
For the rubber thing, so did you use like, are those like the feet that you put under your turntable, or?
Yeah.
So one for each foot. You didn't build any platform or anything like that. You just put the feet of your existing turntable into those.
No, I don't have any feet on my feet have always been sort of just, if I put some feet on the floor that I was putting it on the shelf I was putting it on, there was no screws or anything physically connecting it to the turntable. It just sat on those things. So I just took those out, and now the turntable sits on this.
Sits on the direct. I
and
see.
that goes into this.
I see.
Yeah.
Okay.
Yeah. And I have 4 of them, and you move them around so that you can get the turntable absolutely level.
Oh.
Yeah.
Nice. Oh, that was neat. Wow.
So, did you guys talk about the DIY thing that this month, August, before I joined?
No.
So what's up with the DIY meeting? What do we do? Terry, do you have any idea how we're going to do this, or we're going to do or not do?
I'm sorry. How's that?
DIY meeting, that DIY August event. So what's the plan? Nothing?
No, we decided not to do that.
Can we do something like this, or is it? I'm not sure.
Are you talking about the regular meet that we would have, the speaker contest or something?
Yeah, yeah.
No, we called
discussed
that off.
all off. Okay.
Yeah.
There's no show and tell or anything like that. Okay, that's fine.
Well, show and tell would be a lot easier, but nobody knows when things are going to open up.
Right.
Yeah, yeah. Okay,
That's
just
the
curious.
Yeah.
Yeah, makes sense.
Well, it's unfortunate because I look forward to it, and I think a lot of people do, but it just
Yeah.
wasn't on the cards this year, apparently. So,
Yeah.
so you know what? I was going to do something. We were talking about aligning speakers and drivers in a speaker to get it to balance and all that. And I went and tried to get them out, but I couldn't because they're wedged in there. But I built some, what would you call it? A kind of a curved driver baffle years ago. And I've got 12-inch-and-a-half little mid-range, I guess they're mid-range, but they go pretty high. They go up to about 13, 14,000 without any problems whatsoever. And because it's curved, I did it where the apex of that curve is 10 feet. So if you're sitting 8 feet away, your ears are right in near the point where it converges, the sound.
So the front baffle is a concave surface.
Yeah.
So its focus is like a lens would toward you, toward the center.
It's a focused array, right? Exactly. And but I had it up at I took it up to Canada. Now I did this speaker 14, 15 years ago. I built this thing. So anyway, no, it's it's longer than that. That's about 23 years ago I built it. Anyway, I took it up to Canada to the big meet up there, and some of the guys, most of the guys hadn't heard it, and they seemed to like it real well. They spent a lot of time listening to it. I don't know. Were you there that year? Oh, you weren't there. Okay.
No, I that was before I made it up. Maybe Howard was up there. I don't know.
Yeah.
Not that long ago, no.
I think I was up there
Yes, you were.
at one time. Yeah.
And they seem to like it. I don't know. I thought it was pretty good, but you know, I build it, so I can't. I feel kind of I don't know, getting in deep
There
water,
was-
start bragging too much. So
There was definitely a sweet spot with that focused array.
it was, but you know something I had never considered. I figured, well, it all comes down, and if you're sitting about 8 feet away, your ears are in that cone of sound, right?
Yeah.
Because it tapers to a point. What we found out is when you're beyond where it converges, you also get very good sound. I never tried it because it was made for the rooms of my small house, and that was one of the reasons I made it that way. And I used my room size as the point where I wanted to be listening. But it seems to work in outdoors or in greater spaces too. So I don't know. That was something I never even thought about. So it did work.
Oh, cool.
And I think that you would like to hear them sometime. I should bring them. They're stuck over in the corner, but I can bring them out. They sound pretty good, I think. Dave's heard them. I don't know. Maybe I'm bragging too much. Tell him the truth, Dave.
No, they sounded good. Since you have 12 drivers in the array, they all tend to smooth it out, the overall response pretty well.
Yeah.
It sounded very consistent.
Yeah, Dave,
Yeah, Dave, or no?
well, anyway, yeah.
Yeah.
But we measured them. It was pretty flat out to about 18,000, 17,000, something like that. From about 33 hertz up to about 18,000, yeah.
Neat.
The thing, Dana, you might know about this, but Parts Express got my attention there. They have this curved thing over there. Have you seen it?
Oh,
but it's
yeah.
actually curved, but it's not really focused, like, you know, to you.
That
It's
one is
actually
convex.
Convex, the other way around.
Yeah.
How does it work? I don't know.
He has a tapered power scheme going on with that, so it makes more of a flat wave front out in front of it.
Oh, even though it's
I
just
think
curved, it's
Yeah.
short. Oh, I see.
He's playing with the phase of that thing to get it to
Got a,
form right. Yeah.
I see.
he did a lot with power taper, I think.
Yeah.
Yeah.
I did a little model a while ago. This is 2 different spherical sources. And what was not obvious to me was that, well, when you've got a bunch of drivers together, and say in this instance, they are organized on a sphere, that you get roll off at the high frequencies.
Right.
And so you have to actually boost the high frequencies on those arrays to make them be flat. And so in that array, he talks about, how it's got such uniform distribution, which it does, but what they rarely mention is, they really have to boost the high end on it.
So it comes with its own amplifier on that kit, if I remember right.
Oh, wow. I see.
Yeah, so it does have a very even distribution because of that, and then the shading, whatever they do, where they lower the amplitude to different drivers depending on where they are in the array. But he based it off some research done by the Navy for sonar, and so it's a great. I'm sure it's got a really nice sound with a lot of dynamic range because of all those drivers. It's very low distortion, again, because the drivers don't have to work very hard. So it looks like an interesting project. But yeah, you got to get the 32 drivers or whatever. Oh my gosh, yeah. It's a thing. But yeah, they do that now in a lot of sound reinforcement where they'll have those curved arrays. His is based on using the ground plane to build the bottom half of the array. So it uses that reflection, so the array is curving back like this. So it's really forming a virtual large curved array. And so yeah, it's a fun idea. The other guy, what's his name with it was in my brain and it just went out. Our man, Phase Linear man, who now does his really tall array, and his idea was to make the line array so tall that it touched the ceiling and the floor. So you got
It has to.
Bob Carver.
Bob Carvey. Yeah.
Yeah.
And so he's got a different take on that. Lots of,
Well, Bob didn't design those. Actually, the guys that did, one of them was the owner of what's that audio store
oh,
that has the top end stuff anyway in town. And then he went down to California and he just did the management, but he was actually working for another company. And then the other guy was at God, I can never pronounce his name. The one that did arrays, the tall arrays later on. What was that guy's name?
oh,
Anyway, they're
yeah.
both Seattle guys.
Okay.
And they're the ones that designed that. And actually, Bob Carver just kind of told him kind of what he wanted. And they worked it out. And he said, because when I talked to him, he said it was really rough because no work had ever been done on anything like that before. And the first part of the problem was it was open baffle. And they had Tongan or whatever it is, it's a Japanese company, designed some woofers that they put the specs on it that they wanted. And then this Japanese company built them. But they had a queue of like 3.4 on those.
Oh, yeah. Maybe you're talking about the Amazing.
Yeah, the Amazings. And
Yeah.
so anyway, they found out that it didn't have to be that much, but the idea was to get a lot of sound without having to equalize anything too much.
Yeah. Yeah.
And later on, they got away with 2.85, I think it was, on the second edition.
Right.
That seemed to work pretty good.
That's amazing. That's amazing. There you go. I said it.
That's pretty high Q. And there no manufacturers made anything like that. I mean, they actually had to custom make them.
Oh, yeah.
The guys, because nobody ever wanted drivers with a queue like that before, you know.
Right.
Yeah, I'm gonna head out, have some lunch. So,
Yeah, I was going to say, I think we're losing people, so maybe we'll, unless there's somebody who wants to add
see you all
something.
next time.
Shall we call it a day? What do you think?
Sure. Michael was asking whether we should meet like twice a month or more frequent, or
He
says
wants-
it's fun. So up to you guys. I'm not sure. Dana, I think you're scheduling these things. I'll leave it to you.
Yeah, I guess we'll see.
Benan.
Yeah, if you guys want to, we could do it. Yeah. I figure we got the large
The
other
large
meeting
one. Yeah.
on alternate week. So I don't know. I guess we'll see what happens with that meeting.
Yeah.
And
Yeah.
yeah,
Right, so that is 2 per month with the other one.
right.
Yeah. I think
So, yeah. and
that's probably enough. Yeah.
And there's always AES. You could get your third meeting in.
Well, I did want to ask one question. It's a little untimely just because we're kind of closing out here. But while we were talking about the line arrays, I think that there must, with the speaker that I'm building, since it's 5 drivers in a row, there's something in common with the line array, even though they don't all handle the same frequency range. There's a bunch of overlap. And I don't know, I mean, that it really, I don't know what the upshot of that is one way or another. If I'm close to them, you know, you can actually hear the lows coming down from down lower and the highs coming from a little higher and all. But does anyone have any experience with the reflection on that kind of thing, where you have a bunch of drivers in a multi-driver system that's not all the same driver, and you know, just any ideas about what that does and what to look out for and whatever. I mean, I'm already building the thing, but it's just you know, it's I'm liking the way it sounds, but is there any design theory that probably goes way back about that type of thing? About, you know, I mean, there's the idea of the single driver being an ideal point source kind of thing and having a particularly fine kind of imaging. But I think I'm also finding that the open backed, the dipole type actually makes that less important, makes that less significant somehow. Like having more drivers in a taller arrangement seems to go along with having an open bath design. I don't know if anyone has any reflections on that or not, but that was bouncing around in my head before we started closing out, so I thought I'd throw it out there.
Yeah. Well, maybe
Not particular-
we'll all noodle on it. Yeah.
Okay, that's fine. Me too. Well, very good. Thank you for putting it together, Dana.
Oh, no problem. Yeah.
Yeah, I appreciate it.
Yeah. Fun to hear everybody's stuff, and yeah, excellent. Good times.
Yeah.
All right, gentlemen. Well, have a great rest of your day.
All right, very
Take
good.
care. Yeah.
All right.
Okay, everybody. Okay,
All
bye.
right.